as we've talked about in the previous problems, we're still looking at our same formulas that when we're talking about a 30, 60, 90, right? 30 degrees by 60 degrees by 90 degrees. Looking at B being A times the square root of 3 and C being 2 times A. So the short side, right, our short leg is A, our long leg or our long side is B, and our hypotenuse is C. So what happens when I have this? Well, if my long side B is my given, then I need to determine A and C. Now, remember when we did the last one, we had to solve for C first because we were given C, so that's how we determine A. Well, now we're given B, and so we have to solve for A because once again we have to know the length of A to solve for C. So there is a proper order, unlike the short side where I can do either one, either operation first, and when I have the hypotenuse, I have to do C. I use C first. But now we're doing the long side, so it is important that I do the equation that solves for B before the other one, because that's what's going to give me A. So I have B equals A times the square root of 3. Well, in problem number 14, we're told that B equals 11 times the square root of 3. So if B equals A square root of 3, then technically what I'm doing is I'm saying, okay, 11 times the square root of 3 equals A times square root of 3. So I want to solve for A. So this is the variable that I'm solving for. So in order to do that, that means I need to get rid of the square root of 3. So that's going to cancel that out. But what I do to one side, I have to do to the other. So then if I look at this, I can make a quick, simplify pretty quick by saying, okay, well, the square root of 3 goes into square root of 3. So 11 on this side, leaving me A on this side. So then A is equal to 11. And, I don't have to necessarily write it this way. I can write it, 11 equals A also. It's the same thing. But you're probably more familiar seeing it this way. All right, so now another way to look at this, honestly, is if I look right here, right, B equals 11 square root of 3, right? Well, if my formula is B equals A square root of 3, then simply looking at it right in here, I can see that A is going to end up being 11 because it's filled in right there. So that's just one way that you can see real fast what A is in this equation. But the proper forming of solving is what I did over here. This is how I would solve for it. But again, because 11 is given here, I can make the connection that A must be 11. Okay, so take a look at that minute, and I'm going to erase it, and you can see what I mean. Whoops, a little crazy there with my eraser, didn't I? Go back and fix this real quick. Okay, now we're back going. All right, so I've solved for A. Now I want to solve for C. So if C equals 2A and A equals 11, right? We've already established that A equals 11. Then simply say C equals 2 times 11. Therefore, C equals 22. So then define the length of each side, and I kind of made a mistake at the very beginning. I should have went in at the very start, and I should have said that this is 11 square meters because, like I've told you, it's very important to know the units. So this is meters, and this is meters here. So then for my final answers, I was given B in the initial equation, which said that 11 is the square root of 3 meters. And I solved for A down here, which told me A was 11 meters. And then I solved for C right here, where C equaled 22 meters. And that's how I would do number 14 and 4.4.